Hello and welcome to you all, and today we are going to learn about RIPS architecture, and this architecture is developed by Uber's engineering team, and they use this architecture to rewrite their driver's application due to multiple problems. One of the very prominent attribute of this architecture is this architecture is completely business logic driven as opposed to the other architectures where design is majorly driven by the UI layer. One of the very good point of this particular architecture is it comes with a tooling framework, so that helps you in terms of the code generation and the static code analysis also. So as I always say that to know about a good architecture is a good thing, but what is more important is to understand that in which particular situation you can use this architecture. So before starting this session, first of all we will try to understand that in which situation you can choose RIPS as an architecture for your projects. I am giving you 6 points basically, so if they are meeting to your requirement, then you can choose RIPS architecture for your project. Number one is cross-platform need. So if you are looking for an architecture that can go hands in hand with iOS and the Android, both of the platform, then RIPS is a very good choice. Second is nested state. So if your project is having too many nested state and you want to avoid the global state modification problem also, and if you don't understand the concept of states, then you can refer one of my tutorial on RX Swift series. There I mention the concept of states in a very detailed manner. One of the very quick example I can give it to you. There is a user in your application and he is currently logged in. So logged in is a parent state and he can be online and offline on the basis of his availability. So these two are the nested states for that particular user. So this was a very simple example, but your application can have too many nested states, right? So if you are in a situation where you need to handle multiple nested states and there is a multi-threaded environment also, then RIPS is a very good architecture to deal with this kind of situation. And third one is if your application is business logic intense. What does it mean? Every application has the business logic, right? So business logic intense applications are those applications where against a single action of the user, multiple activities or multiple functionality could get triggered in your application. We can take very quick example of Uber's application itself. For example, if you are giving your pickup point and your destination as the input, and then you are clicking on the search button, then in the background multiple activities can get triggered, right? For example, the ecosystem starts searching your nearby drivers. They start taking the, you can say, acceptance from the drivers, and they started assigning drivers to you, and then they give you the notification also that your drivers has been assigned. They calculate the fare also. So you can see that against the one single action there are multiple activities are getting triggered. So these are the applications that are more business logic intense. Fourth point is need of rapid scaling. So if you are looking for an architecture that could be capable of very rapid scaling against the newly coming requirements in your project, then RIPS is a very good choice, because here each and every functionality you create in the form of RIP. Right now I know that you maybe or may not be, you can understand the concept of RIP, that in the later part of this session we will try to explain it in a better way, but for now you can understand this, that here each and every functionality is represented in the form of RIP. So if new requirement is coming in, then you can create new RIPs in your application that can be that can work in a form of pluggable component in your architecture. So that's why it's a very easily scalable architecture without disturbing the existing functionality. Fifth point is business logic as plugin. So if you want to develop your application in a way, suppose a requirement is coming in and you are developing some business logic in your app, and later on when client says that he don't need that functionality, so you should be capable of removing that functionality without any disturbance of your project structure. So to deal with these kind of situations, RIPS is a very good architecture, because here every functionality is represented with the help of a RIB structure, right? That can be easily pluggable. So to deal with these kind of situation where you want to have your business logic in a form of pluggable, or you can say attachable or detachable components, then RIPS is a good choice. And the last point is RIPS architecture is basically suitable for the bigger projects. Don't try to use this architecture for the smaller application. It's moreover a kind of Viper type architecture, so try to use it in the large applications only. So with the help of these 6 points, I think you will have the idea that in this kind of situation you can easily use RIPS architecture for your project. So before starting the coding sample, there are two very important things to understand. Number one, what are the components of RIPS architecture, and number two, how data flows among these components of the RIPS architecture. So these are the six very major components of RIPS architecture. Number one is router. So if you remember, we have already done a discussion on the router component in MEVM C+A architecture. So the main responsibility of router is to maintain the navigation logic in your application, and here router is basically responsible for attaching and detaching the RIP component. Right now, don't worry about the understanding of the RIP component completely. Once you jump into the coding section, you will get the better understanding what exactly the RIP structure is. Now second is the interactor. So interactor is almost same as the view model in the MVVM architecture. So its main responsibility is to perform the business logic processing for you. And the third component is builder. So the builder is basically responsible for instantiating all your RIPS classes. What builder basically do for you is it separates the class logic from its creation and gives you a ease of mockability when you write the unit test cases. Other three parts are presenter, view controller, and component. So presenter is basically responsible for converting your business model into your view models and vice versa. So if in your application there is a requirement and where you are getting the data from your web services or from your API, and then you are converting it into the models, but to display it into a particular view layer, you need to do some modification. That means you need to convert your data model or your business model into view model basically. So that responsibility goes into the presenter layer. But one very important thing to understand, if this kind of conversion is very, you can say, minute and doesn't depend upon a very heavy logic, that you can completely avoid the presenter layer in the RIPS architecture. And at that time, you need to write that particular code that is responsible to convert your data models into view models, either in the interactor or into the view controller. But if you think that it's a bigger logic, then you can use presenter layer also. After that, there comes the component that is view controller. So view controller is nothing, it's a kind of dumb UI view, and we don't write any logic in terms of the business logic processing into the view layer. It is completely responsible for the creation of the view and displaying the data for you. Last part is component. So component is completely responsible to supply all the dependency for your RIPS classes. So these are the six major components of RIPS architecture, and now we will try to understand how exactly data flows among these components of RIPS architecture. And once we get the understanding that what are the different components and how data flows among these components, then it will become much more easy to understand the code structure or the code sample for the RIPS architecture.
With the help of this particular diagram, we will try to understand how data exactly flows in RIPS architecture. So the very first layer is the view layer. So we will take the example of login button press to demonstrate the data flow in the RIPS architecture. So from the view, if user is pressing the login button, then corresponding action will be reaching to the presenter layer, and against that particular action, if any business logic processing is required, for example, you need to call an API obviously, then that logic will be written inside the interactor layer, and whatever response you will be getting from the API, ultimately it will be getting converted into some business model. But to display it onto the login screen, maybe in the form of success alert, then you need to change that business model into some view model. So that logic you will write inside the presenter layer. So whenever the request reaches from the presenter to interactor, then after completing that business logic processing, interactor gives presenter the business model, and the conversion of that business model into the view model happens inside the presenter layer, and then presenter gives the view model to view to display that particular data into the required format. So whatever logic that is required to display data into the view or to make view ready to display the data with the help of that particular view model, then that logic is written inside the presenter layer only. Now there could be a situation also that on the press of particular button, you need to move on some different screen also. For example, you want to move to the sign up screen, right? So that kind of navigation logic you always write inside the router layer. So whenever you need to write any Navigation related logic you will write only inside the router layer. In the ribs architecture, we say it as the attaching and the detaching of the rib. Then those two functions will always be written inside the router, but router will be always dedicated for the navigation logic only. Now we will come into the builder component. The part that builder plays basically, it's to create all the ribs classes. Why always we say it as a rib? Because every functionality in the ribs architecture is represented with the help of rib structure. So rib, in the rib, R is router, I is interactor, B is builder. So that's why we call it as the ribs architecture, because these are the three major components that formulates ribs architecture. And component is the layer which supply all the dependencies to the builder. So builder basically separates your class logic to its creation logic, and whatever dependency your class need, that is getting supplied by the component layer. So that's how the data flows inside the ribs architecture. If you remember, in the starting of this particular session, we had a discussion that ribs architecture comes with a tooling framework or the productivity framework. So with the help of this particular tooling framework, you get the ability to generate the templated Xcode files or the templated Xcode classes for the rib structure for a particular functionality in the rib architecture. So that provides you a facility to generate the pre-written classes, and you need not to invest your time in terms of writing the boilerplate code for the rib architecture. So if you download the official sample of the rib architecture, then you get this tooling folder inside the iOS sample. So you can copy this folder to anywhere or maybe in the root directory of your project, and after that you need to run this install xcode template.sh script. If your script run is successful, then you will be able to see the output just like shown on the screen. So you will see the message that ribs has been set up in the Xcode. Select new file to use the ribs templates. Now whenever you select new file from the file menu of the Xcode, then you will be able to see the ribs template installed in your Xcode. And only thing you need to do is, suppose you are going to create the rib structure for the login functionality, just select the rib Xcode template and name it as the login, and it will generate the rib structure for you on the fly. For the demonstration purpose, we are taking very simple example here. In this sample, we are having two screen hierarchy. Number one is login screen and number two is sign up screen. And for the sake of simplicity and understanding, we are not implementing any web service in this sample. That means this application or the sample doesn't contain any networking component. Our focus will only be on understanding how we can implement the rib structure for a particular functionality while implementing login and sign up screen. So now it's time to open your Xcode and start building the sample. First thing I would like to show you in this particular sample is how you can use those Xcode templates or the ribs template that you have already installed with the help of shell script. So if you go into the file menu and if you select new file, then in this particular screen you will be able to see all the installed ribs template. And if you select this particular option and you click on next, suppose you want to create the detail screen, then you can name it as detail. And when you click on the next button, it will basically generate all the ribs file for you. And now you need not to write any boilerplate code for setting up the ribs architecture. So if you see that here you are having the basic code of detail router, you are also having base structure for the detail view controller, and same is for the detail builder and for detail interactor. So this part was just to demonstrate you how you can use those ribs template that you have already installed in your Xcode. To make this sample running, you also need some of the Cocoa pods. And for now, I am assuming that you are completely aware with the Cocoa pod structure, and you also know how to install Cocoa pods for your application. So on the screen, you can see the required Cocoa pod file, and there you need to install 3 Cocoa pods in your application. So one is the ribs, another one is the RX Swift, and third one is the Anchorage. Anchorage is the Cocoa pod that is written over the NS layout anchor API, and this basically helps you in terms of setting up the NS layout constraints for your UI elements. This could be the part of a completely separate discussion if we are jumping into the detail of this cocoa pod. So for now we are just leaving it here, and you need to maintain this cocoa pod file in the root directory of your project, and you need to have these 3 pods to make this sample running. First screen that we are going to implement is login view controller. And the first thing you need to do for this particular screen is you need to import all 3 cocoa pods that you have already installed. Next thing is to implement the login presentable listener protocol, which is having basically 2 functions that are corresponding to the button press or the user interaction for the login and the sign up. So when user will press on the login button, then this function should be fired, and when user will press on the sign up button, then this function should be fired. Moving forward, when you see the implementation of login view controller, this is completely dedicated to the setting up the UI elements. Here you can see we are doing that thing, and in the configure layout method we are just setting up all the constant with the help of this Anchorage cocoa pod that you have already imported. As a next, we are having 2 private functions in login view controller. One is login and another one is the create account. So whenever there is a request of the navigation that you can see on the line number 72, then that request should ideally be reached to the router. And for this particular screen, that is login view controller, listener will be login interactor class. And how this will be setting up, we will show in the next part of this particular demonstration. So for now, you need to understand that for this particular login view controller, listener is login interactor. And moving forward, when you see that there is one more protocol that is login presentable, and if you jump into the implementation of login presentable, it is having 2 methods basically. So here you can see that line, and that is depicting the purpose of that particular protocol, that you need to declare the methods that interactor can invoke the presenter to present the data. So ideally this protocol should be implemented by the presenter basically, but right now we are not having the condition where you need to convert your business model into the view models basically. So we are avoiding the presenter layer here, and what we are doing is we are implementing this login presentable protocol into login view controller. So if you remember, I have given you one statement that if you are not having presenter in this particular architecture, then that small logic that is related with the setting up the logic of UI screen need to be shifted in the view controller itself. So that's why this login presentable protocol is being followed by the login view controller, and we are having these 2 methods for showing the activity indicator when API will be hit, and when there is any error is coming, then we will call this particular function that is show error alert. So this is the overall implementation of login view controller. There are 3 things that are important. Number 1, in the view did load, you are just setting up the complete UI. As the second point, you implemented those 2 functions, login and create account, that will be called on the listener of that particular view controller, that is basically the login interactor, and how it is getting setting up you can see in the builder class as the next part. And third thing is you need to implement this login presentable protocol, that is basically having the function where you need to change the state of your UI whenever any business logic processing is started happening or it has been completed. Next class that we are going to implement is login builder, and if you remember that builder is the layer in the RIPS architecture that is responsible to create all the RIPS classes for you. So the very first thing that we are going to implement in this login builder class is the login dependency protocol. So this protocol basically declare all the dependencies that is required by this particular RIB structure. But one thing to remember, these dependencies could not be created inside the builder. Basically they should be coming from any parent RIB structure. So right now for the login view controller there is only one dependency, that is the web service. So we are declaring this particular variable here where web service, that is of type web servicing class. And if you move ahead in this particular class, another class that we are going to implement is login component. So the responsibility of login component is to supply all the file private dependencies that is required only by this particular rib, and they are not coming from any outside class. The only thing is they are required only by this particular rib internally, so we can declare all those dependencies here only. One quick example I can give it to you. For example, your application is using any kind of API secret or the application secret that should be passed to the login web service, that you can declare it here. But the ideal way to declare these kind of information is with the help of config file separately. But just for the understanding purpose, I am telling you, if there is any particular dependency of this particular login rib that is not coming from the outside class, then you can declare it here also. Now moving ahead to this particular class, there is one more protocol, that is login buildable. This is having only one method, that is build, and this is responsible to build all the related classes for this particular rib structure. If you look into the implementation of class login builder, it is inherited by the class builder that is coming from the Cocoa pods that you have installed. You can see that, and you can also see the implementation, how this particular builder class is implementing. It is having a property that is dependency, and it is of type dependency type. Moving back to the class, so our login builder class basically inherited by the builder class, and two protocols it is following. One is login dependency and another one is the login buildable. So with the login dependency, you can see that this web service property is coming in to the login builder, and another thing is with the help of login buildable, this build method is getting into this login builder class. Now pay very close attention to the function build at the line number 38. It is taking one parameter of type login listener protocol. So if you jump into this login listener protocol, it is having only one function, that is dismiss login flow. So this will be implemented by the root rib basically, because if you look into the navigation hierarchy, before the login rib we are having the root rib. So when the login flow is completed, you need to inform back to the root rib that login flow is completed, and now you need to dismiss the login flow. So that's why this login listener protocol is created. And see one more thing, that the listener of Interactor, that is login Interactor basically, is becoming that particular object, right? So the thing is, with the build method we are supplying a listener, that is basically root rib, for the login flow, and this listener is getting passed into the login Interactor. So when the login flow will be completed, then this listener will be informed that login flow is completed. Now you need to dismiss the login screen. Now move to the line number 39. Here we are just creating the object of login component, and this login component basically having one property of type login dependency, because we know that the role of component is just to supply the dependency of current rib. So that's why it is having only one property. And at the line number 40 we are creating the object of view controller, and at the line number 41 we are creating the object of login Interactor, that is basically getting the two parameters. One is the view controller itself, and another one is the dependency in the form of web service, and that is coming from this particular component object, that is component.dependency.web service. This line you already understand that we are just telling the login Interactor that root rib will be the listener of login flow. So this is the purpose of this particular line. And at the line number 45 we are basically building the sign up builder and giving up the component.dependency as the property, and at the line number 47 we are returning the object of login router. So login router is basically the object that will manage complete navigation flows from the login screen, right? So that login router has three properties: number one, Interactor; number two, view controller; and number three, that sign up builder. So the build method is doing so many tasks here. You need to keep those tasks in your mind very carefully. Now we will implement the login interactor class. But before implementing the login interactor class, you need to understand 3 points basically. So your interactor need to establish the communication between the router, between the view controller or the presenter, and the root router also. So for that particular purpose, you need to implement 3 protocols. The first protocol is login routing. With the help of this particular protocol, your interactor will be able to communicate with the router. So when user will press the sign up button, then this function will be fired, and when the sign up flow will be completed, then this function will be fired. So this particular protocol is just required to establish the communication between your login interactor and the login router basically, and this protocol will be adopted by the login router. First thing. Now second thing, you need to establish the communication between your presenter and your view controller with the login interactor. So this login presentable protocol is responsible for that. Here, with the help of this particular protocol, your interactor is able to communicate to presenter or the view controller to tell them that you need to present the data or you need to show the alert, right? So these two functions are dedicated for this particular purpose. And now the third protocol is login listener. This protocol is basically implemented by the root router, because when your interactor will inform to the root router, that is login router basically, that login flow has been completed, then root router need to dismiss the login flow with the help of dismiss login flow function. So these three communication from interactor basically to router, to view controller, and to root router, these are established with the help of these 3 protocols. So communication between your interactor and the login view controller is happening with the help of this particular protocol, right? So there is also a point where you need to send one communication from login view controller to login interactor. How you will tell your interactor that login button is pressed or the sign up button is pressed? So for that we are having one more protocol that we have already discussed perhaps, that login presentable listener, that is present in the login view controller. So here we are having two functions. One is corresponding to login and another one is corresponding to the sign up. So when we implement this particular protocol on the login interactor, or login interactor is following this particular protocol, then we are getting these two methods. So on did tap of login, we are basically telling presenter. So if you remember in the builder class, what we have done is, when we are creating that login interactor, we are sending login view controller as the presenter, because we are not having here presenter layer, right? So in the login interactor, when we order presenter to show activity indicator, then this logic basically goes into the login view controller, not in the presenter. And after that, at the line number 59, we call the login web service. And again, if the result is success, you can do any processing, and you can ask your presenter to remove the activity, that is basically view controller for you. And if in case of the failure, you can order your view controller to show the error alert, right? So this connection of interactor to presenter is basically established in the builder in this particular line where your presenter is view controller. So this is the implementation of did tap login. And on the did tap of sign up, because there is a navigation flow, then you need to tell your router, that is basically login router, right, that you need to route to sign up screen. And when we will discuss the login router, we will see the implementation of a route to sign up method also, but for now this is sufficient for the understanding of login interactor class implementation. So 4 points to be remembered, very important. Number 1, you need to establish a communication from interactor to router, that happens from the login routing protocol. One communication you need to establish from interactor to your presenter or view controller, that is happening from the login presentable protocol. And one communication you need to establish from your interactor to your root router, that is happening with the help of login listener. And Another communication from login view controller to your interactor whenever any button is pressed, that is getting established with the help of login presentable listener protocol. So this was the implementation of login interactor. The last class that we need to implement the rib structure of the login functionality is the login router. And now here is a very small but important point to understand. The parent rib of the login rib is the root rib, but the parent rib of the sign up rib is the login rib, because the sign up flow is getting triggered from the login screen. So that's why we are having this protocol sign up listener, that is having only one method, close create account flow. When the sign up flow will be completed, then you need to tell login interactor that you need to close or you need to detach the sign up rib from the navigation hierarchy. And if you look into the implementation of login router class, there is one more protocol that it is getting followed, that is login routing. And with the help of this particular protocol, your interactor is basically telling to router that you need to route to sign up, you need to detach the sign up flow. So with the implementation of these two methods, we are getting this functionality implemented in the login router. So the main purpose of the login router is to maintain the navigation logic or to attach or to detach the particular functionality rib. So it's the login router and the sign up flow is getting triggered from here. So here we are having two functions, route to sign up and detach sign up basically. So this was the implementation of login router class. The next rib structure that we need to implement in this sample is sign up rib basically. So in terms of the structure and in terms of the understanding, sign up rib will be exactly same as the login. The only thing is I'm not going to explain sign up rib in the detail because it has been already very long tutorial till this particular point. So the important is to understand how we will establish the root label of the rib through which the control of application will be started. So rather than explaining this sign up rib for you, I will try to explain the implementation of root rib structure so that you can understand that how the control flow get started into the ribs architecture. For the sign up thing, you would be able to understand by yourself if you understand the login rib completely. Root rib is basically the top level rib in this particular sample, and this is also the parent of login rib. And first of all, we will see how the root router is getting implemented. So login listener and the home listener, these are the two protocols through which login interactor and the home interactor basically communicates with the root router. And they, with the help of these two protocol, root router basically come to know that the login flow has been completed or the home flow has been completed. Then root router need to detach that particular rib from the navigation hierarchy. Another protocol is the root controllable, that is having only one method of replacing screen, that is just dedicated to add the next view controller into the hierarchy depending upon the logical situation. So if you look into the implementation of the root router class, this is not very much complex and almost the self-explanatory. So the thing is, with the help of this root routing protocol, this is one of the very important protocol for the root router, that is having two methods basically, attach login and attach home. And with the help of these two functions, root router is basically able to provide you the functionality of attaching the login or attaching the home flow. So this was the implementation of root router basically. Next class that we are going to implement is root interactor. So I hope you remember the structure of login interactor. Then the structure and the design will remain exactly same. The only difference is for the login rib, there is a parent rib, that is the root rib, but for the root rib there is no parent. Apart from that, everything will remain almost same. So the first protocol that we are going to implement is root routing, and this protocol is implemented by the root router, and this is responsible to establish the communication between the root router and the root interactor basically. And it is having two functions that we have already discussed. One is for attaching the login flow and another one is attaching for the home flow. Next protocol is root presentable. So this protocol is responsible to establish the communication between the root interactor and the root view controller or root presenter, because root presenter is not implemented here, so that responsibility comes to the root view controller. So if you see that root presentable protocol will be implemented by the root view controller, and the next protocol is root listener. So you already know that there is no parent of root rib, so we need not to implement this particular thing, but it is here just because it is generated by the Xcode template basically. Now next on the line number 20, there is the class root interactor, and it is following and it is the you can say child of presentable interactor class that is coming from the Cocoa pod basically, and following two protocols, that is root interactable and root presentable listener. And one important thing here to understand is on the lifecycle method of the root interactor on the line number 32, that is did become active, we are calling root router to attach the login flow. So whenever did become active lifecycle method in the root interactor will be fired automatically, then we need to tell root router to attach the login flow. Going forward, there are two protocol implementation, that is login listener and the home listener. So this thing, if you remember, we have already discussed. So whenever login flow will be completed, then we need to inform root interactor that now you need to dismiss the login flow and attach the home flow basically. And on the logout, what you need to do is you again need to implement you need to come out from the home flow basically, and you need to attach the login flow again. So this is the implementation of root interactor. Implementation of root view controller is really easy. I am leaving it for your read now. Just take a look, and then the important part is this function replace screen, and this logic is completely dedicated to set up the next screen as the child view controller in the navigation hierarchy. So the last class that we need to implement in the root rib structure is root builder. In terms of the structure and design, it is exactly same as the login builder. I am scrolling the code slowly so that you can have a look. And whenever you want, you can pause the screen and you can pay more attention to the particular section of the code block. So this is the implementation of root builder. This is the place from where application flow basically starts, that is app delegate. In the app delegate, we are having one variable launch router that is of type protocol launch routing, and this is coming from the Cocoa pods that you have already installed. And then with the help of root builder, we are creating a launch router with the help of build method, and then we are assigning this property launch router to this particular object. After that, on the line number 24, we are calling the method launch from window on the launch router. If you go into the definition of launch from window method, you will see this particular code, and the line number 47, this load method basically initiate the complete flow, and then you assign the window property of app delegate. So this was the implementation of application did finish launching with option. And apart from these classes that we have discussed, you need to implement one more rib, that is home rib. And in terms of the structure and design, it is exactly same as the login rib. But I understand that this is a very complex architecture and its implementation is not also very simple. So for that, you will be needing this sample code, and you must be having multiple queries also. So for that, always feel free to drop me an email on my email ID, that is venugopaltiwari@gmail.com. But only thing you need to take care is always mention subject in the format, that is VGT in capital space vertical slash space name of the architecture. So this basically helps me in terms of filtering the emails from the thousands of emails that I daily receive. I will be very happy to respond your each and every query, and I will try to send you sample code within 24 hours. Here we are ending this particular tutorial on the RIPS architecture. In the coming future, we will try to come up with some of the very good architectures and the design patterns for the mobility applications. Till then, I will say only one thing, that you need to stay motivated and keep learning with us. Thank you.